Hello friends, I am Rohit Kumar Rudrapa Wagdarikar, working as an assistant professor in Computer Science and Engineering Department, Walchand Institute of Technology, Solapur. Today we are going to discuss about the deadlock and its necessary conditions in operating system. So now in learning outcomes, at the end of this lecture or session, students will understand the concepts of deadlock and its necessary conditions, which includes the definition of deadlock, mutual exclusion, hold and wait, no-preemption, and circular wait. Now what is deadlock? Deadlock is a situation where all the processes are in waiting state. The processes request the resources. The resources are not available at that time. So, process entered into the waiting state. The requesting resources are held by the another waiting process. Now both the process are in the waiting state. This situation is called the deadlock. Let's look at this diagram. In this diagram, we'll have the two process, process 1 and process 2, and the two resources, resource 1 and resource 2. So now here, process 1 is waiting for the resource 2, and process 1 has already held one resource called the resource 1. Now again at the process 2, resource 2 is assigned to process 2 and process 2 is waiting for resource 1. Now if we look into this situation, process 1 is already allocated to the resource 1 is already allocated to the process 1 and resource 2 is already allocated to the process 2. And now here in this situation, process 1 and process 2 are requesting for those process, those are already held by the another process. So now here it creates the cycle, means this situation is called the deadlock because process 1 and process 2 are both in the waiting state. To complete this task, they need their different resources. So now this situation is called deadlock. Now, deadlock system must be satisfied by the following conditions: mutual exclusion, hold and wait, no preemption, and circular wait. These are the four necessary conditions. If our system is reside in these four situations, then we call it that situation is nothing but the deadlock situation. Now let's see what they indicates. Now first one is a mutual exclusion. Mutual exclusion, it uses for the concurrent programs. It uses to prevent the race conditions. It prevents the simultaneous access of shared resources. It uses with the critical section, a piece of code in which the process or thread access the shared resources. Process or threads first lock the mutex before entering into the critical section. After completion of the task, it unlocks the mutex. So now if we'll look at these general definitions of this mutual exclusion, when multiple programs are executing concurrently, at that time, this mutual exclusion is needed. So now, even to prevent the race condition, now race condition is also there. Means what? Now P1 and P2 are the two processes and both the processes are sharing the some memory location. Now P1 and P2 are both the updating the values of that shared memory. That's called the race condition. So now critical section. Critical section is a section where the different process comes for its execution. In this section, at a time only single process can enter. That's why it's called the critical section. And to provide the proper mutual exclusion, will uses mutex locks. Now it uses the lock and unlocks. Before entering into the critical section, first of all we need to lock it, and when we'll complete our task in the critical section, then we'll need to unlock it. So that's nothing but the mutual exclusion. Now look at here in this diagram. The P1 first acquires the lock before entering into the critical section by performing the lock operation. It means to acquire the lock over the critical section, first we need to execute the lock operation, and when that process will complete its task, now he wants to release the critical section. At that time we need to perform the unlock operation. So now here, after completion of task, P1 will release the lock by performing the unlock operation. Now hold and wait. Hold and wait condition states that the process is holding onto the resources that may be required by the other process. The key point here is that the process is holding onto those resources and will not release them until it gets access to the requested resources which are being held by the other process. That is nothing but the hold and wait. Now look into this diagram here. In the diagram there will be the two resources R1 and R2, and P1 is the process. Now P1 is holding R1 and P1 is waiting for R2. Now here in this situation we'll call it as a hold and wait. Now no preemption. No preemption means once has obtained a resource, the system cannot remove it from process control unit until the process has finished using the resources. Once a process is holding resource, that is once its request has been granted, then that resource cannot be taken away from that process until process voluntarily release it. Now preemption of process resource allocation can prevent this condition of the deadlock. Process must release resources and request again. So now that is nothing but the no preemption. It means, simple word we can call it as a, while execution of any process there should be no disturbance in the execution. That's called the no preemption. Now last one is circular wait. When two or more processes are each waiting for the another to release a resource, or more than one process, more than two processes are waiting for resources in a circular chain, this situation called the circular wait. The processes in the system forms a circular list or chain where each process in the list is waiting for a resource held by the next process in the list. Means in this circular wait, different processes are there and each process is holding the resources, and now here each process is requesting for the resources also. Now here the resource becomes the chain. It means P1 is requesting for the P2's resource, P2 is requesting for the P3's resource, P3 is requesting for the P4 resource. In that way here it will create one circular chain. That's called the circular wait. Now look into this diagram. Again here we'll have the P1 and P2 are the two processes. Then R1 and R2 are the two resources. Then P1 is requesting for the R1 and resource R1 allocated to the P2, and here request for the resource R2 and R2 allocated to the P1. Now here it's create the circular chain. Now that's called the circular wait. Now let's see one questions. What are the necessary and sufficient deadlock conditions we have learned? Now we'll look at the answer. The first necessary condition is mutual exclusion, means our system must be in the mutual exclusion condition, our system must be hold and wait condition, our system must be in the no preemption, and our system must be in the circular wait. When our system will satisfy these four conditions, at that time our system is in the deadlock. The references are Operating System Concepts by the Galvin, System Program and Operating System by the Dumdere, And here we have used some YouTube channels like TechTube channels, and we have referred some standard PPTs also. Thank you.